Hello curious minds and welcome back to our space lab.
In this episode, we will see how RFID tags work, how to use them, and then we use this knowledge to light up a LED once the signal is received by the RFID receiver. An RFID, or a radio frequency identification device, has two parts to it. One is the receiver and the another is the transmitter. The transmitter can come in various shapes and sizes. These could be cards or key tags like this. A receiver has an inbuilt coil which can be seen going across it. This coil is made up of copper. The coil is energized by the 3.3 volt power supply when we connect the receiver to the Arduino. When the coil is energized, it creates a magnetic field around it. When an RFID tag, which also has a coil inside it, comes in range of the magnetic field generated by the receiver, these are in mutual induction and now the tag is energized. The tag has a small chip inside it which is powered when this comes in range in the magnetic field. You can think of this chip as a small computer. Each computer has its own unique identification or the IP address, and this chip has a unique IP address as well, and this is different from the IP address within this card. So the microprocessor can then say that the transmission transmitted by this chip is the key to the program in the receiver or not, and thus you can use such devices as door keys, as identification chips, as well as unique personal IDs or bank cards. The RFID receiver, which comes with the kit, has, as you can see, many different pins underneath it. This also comes with a connector which needs to be soldered onto the RFID receiver. Once soldered, we can insert the whole RFID receiver into the breadboard to make further connections. The connections are different based on what kind of microcontroller you have. If you have an Arduino Uno, the connections are slightly different than the ones you have to make when you have an Arduino at Mega. Let's see how to make the connections for an Arduino Uno. For this, we would need the breadboard, the Arduino microcontroller, the RFID receiver, RFID transmitter, and 7 connecting wires. So here I have connected all the wires to the different ports from the receiver. The first port, or the STA from the receiver, goes to the port 10 on the microcontroller. The second port from the receiver, the SCK, goes to the port 13 on the microcontroller. The third port, which is labeled as MOSI on the receiver, goes to the port 11 on the microcontroller. The port which is labeled as MISO in the receiver goes to the port number 12 in the microcontroller. The IRQ port on the receiver stays empty. The ground, which is the next port on the receiver, goes to the ground on the microcontroller. The RST goes to the port 9 on the microcontroller. And the 3.3 port from the receiver goes to the 3.3 port on the microcontroller. We also have an LED which is connected to the port 7 on the microcontroller, and the other one goes to the ground. Let's see how the programming is written.
Programming a RFID kit may seem complicated, but we'll use a couple of libraries that will make our lives easier. First, we'll need a Serial Peripheral Interface, or an SPI library. Serial Peripheral Interface, or SPI, is a data protocol used by microcontrollers for communicating with one or more peripheral devices. It can also be used for communication between the microcontrollers. With an SPI connection, there is always one master device, that is usually a microcontroller, which controls the peripheral device. In our case, the microcontroller will control the RF receiver. We'll also need a library that will help us analyze and decode the value received from our RF tag. We'll use an RFID library for it. Let's include this in our sketch too. Then we'll have to attribute the pins to the corresponding connections. Finally, we'll create an RFID receiver class from the RFID library and specify the pins that we've defined. In the setup part, we open the serial connection to track values on the serial monitor. Then we open a connection with the RFID receiver with SPI begin. And don't forget to initialize the RFID receiver class that we've borrowed from the library, with the initialization method that comes from the library. Now, in the main part, we will check if the microcontroller gets any RFID signals. If not, we'll return from the loop, which means we'll start from the very beginning. Then, let's make sure that the serial number of the RFID tag was read. If not, start from the beginning. If we have successfully read serial number value, let's try decoding it. The RFID receiver object has a property called UID, or Unique Identifier. Our goal is to get the unique identifier for the RFID tag as a normal number. We'll use it in our if loop afterwards. First, we'll set the ID value to 0 because we don't know it yet. Now, let's read the ID value from the receiver byte by byte. We'll start with the very first byte, which is byte 0, and with every step increase the byte number by 1. The loop will repeat until we're out of bytes, which you can read from this less sign. Every byte contains a decimal number. Every time we get a new number, we'll add it to the previous accumulated result and multiply the whole thing by 10. In the end, we'll get a unique number. And then print the unique identifier to the serial monitor. Let's play around with our RFID receiver and try finding out our unique ID. Let's try passing the tag in front of the receiver. And we can see on the serial monitor, now we have our unique identifier. We can also use the card and see that it has a different identifier. Okay, now that we know our unique identifier, we can use it to control an LED. Let's complete our sketch. If the unique ID read by the receiver is the one that we have, then light the LED for 5 seconds. Otherwise, don't do anything. Let's check how it works. Pass the tag, and you can see it's on. Now, there are so many things that we can do with the RFID magic. If you are interested in more Arduino videos, then stay tuned, subscribe to our channel, and tell us if you like our videos. See you in the next episode.